Hi, 6th grade. Happy Friday. It's May 8th. Another week of remote learning is soon to be behind you. You guys are doing a great job. I know this is, for some of you, enjoyable to be at home, but for many of you, I know that you're a little anxious to be back either at school or just with your friends and get out of the house. So keep hanging in there. We only have a couple weeks left of school, guys. So we're at the tail end here of another school year, a crazy school year, but just hang in there, all right? So we're going to get through this video, and then you'll have a nice weekend to look forward to, a little break from school. All right, so we're continuing in our discussion of 8.1.3 on the different star systems, talking about galaxies as well. And so that's where we're going to pick up from the last video, and then at the end we will go over the answers to the critical thinking questions from the previous lesson on Wednesday. So, all galaxies are in constant motion. Galaxies tend to congregate and move through space as a unit, spanning hundreds of millions of light years across. So that's a tough thing for us to grasp, just how big it's millions, hundreds of millions of light years big in expanse. So almost inconceivable how big these galaxies are, and they tend to congregate and move through space over these huge ranges. The gas and dust that's contained inside a galaxy is called the interstellar matter. And this is what forms the nebula that give birth to stars that we talked about in previous lessons when we talked about the life cycle of a star. And there are two basic types of nebula. Okay, there's a dark nebula, and this is very dense and cold, and it blocks the light of the stars behind them. And then there are bright nebula, and these emit or reflect light from nearby stars. All right, so if you're asked what the two type of nebula are that form inside the interstellar matter of a galaxy, that's dark and bright. Star clusters, on the other hand, are groups of stars that have a common origin. They are held together by mutual gravitational attraction. So just like we talked about in the previous video, it's that gravitational hold around a common center of mass. It's the same for star clusters, basically. Mutual gravitational attraction. And there are two types of star clusters. There's open and globular. So open star clusters are groups of just a few hundred young stars that are loosely held together by gravity. They're usually located in the bulge of a spiral galaxy. So looking back at the different types of galaxies we studied in the previous video, these are usually located in that bulge. Then we have globular star clusters, and these are dense, ball-shaped groups of older stars, and they're usually located at the center of the galaxy. Okay, so while the open we find in the bulge, the globular we find in the center of the galaxy, and while the open is consisted of young stars, the globular is consist of dense old stars. So there's difference there. So again, if you're asked not only what type of nebula, what are the two types of nebula, there's also two types of star clusters. So that's the open and the globular. And although galaxies are extremely large, they're not the largest units in the universe. So what we mean by that is kind of in size, you know, like people, and then Earth, and then outer space, and the other planets, and then we get stars and galaxies, and we work our way out to get bigger and bigger and bigger and bigger. Well, galaxies isn't even where it ends. There's galaxy clusters now, which are groups of thousands of galaxies under the same gravitational influence. Again, one of those concepts that's like almost incomprehensible. It's hard for us to wrap our mind about it because it's just so expansive and out there in space. When we look up at the stars, it's hard to imagine that there could be thousands of galaxies, each like hundreds of millions of light years wide, and they're in groups, and they're all moving too. And so those are the galaxy clusters. They can contain as many as tens of thousands of galaxies in one, basically, all clumped together. And they get arranged into superclusters, which are groups of galaxy clusters, often spanning millions of light years across. So again, huge, huge, huge. If you get anything from that, galaxy clusters are even bigger than galaxies, and both of them are just immense in size. Light years and light years across. This right here is a galaxy cluster. I actually got this picture from NASA to show you guys, but this whole picture here, this is obviously a very prominent galaxy. but this whole picture here shows you galaxy clusters. And so this image is known to NASA as SDSS J03333 plus 0651, so a very official name that means nothing to us, but is probably a very strategic way of documenting within NASA the different clusters. And clusters like this help astronomers to understand the distant and therefore early formation of the universe. So this tells them a little bit more about what and how God created the universe. And this particular image was taken from the Hubble telescope from NASA. We touched upon the Hubble telescope in a couple other lessons. It was named after a famous astronomer whose last name was Hubble. And it's used still today as one of the major telescopes that NASA uses to view things that require a very powerful telescope to view. And so pretty cool. Real picture from NASA. All right, so now we're going to go over the answers to the critical thinking questions from the last video lesson. So number 1 is, what holds binary stars in place? The correct answer to that is mutual gravitational attraction. All right, so make sure, if you didn't already, pause the video. Just make sure you check your answers. I want to make sure you have the right answers so that you can use them to help you on future assignments. All right. Number 2, why does the central bulge of a spiral galaxy appear redder? The stars located in the central bulge are older and cooler. Remember, we said blue is for really hot stars, while red is for cooler stars. So that's why they're older and cooler. Number 3, what type of stars do elliptical galaxies contain? Elliptical galaxies contain old stars. Again, that was those bullet points I said you want to go back to and make sure you understand the differences between the 3 types of galaxies. So elliptical contains old. What type of galaxy do astronomers believe in the Milky Way is? It appears to astronomers to be a spiral galaxy. So a spiral galaxy. And lastly, number 5, we needed to classify these 5 galaxies as one of the 3 shapes. So the first one here, A, this is an elliptical galaxy. B, this is a spiral galaxy. We see that spiral pattern, just like we see the elliptical shape of A. C, what do you think? This is also an elliptical galaxy. D, this is irregular. There's really no distinct elliptical shape or spiral, so this is irregular. And E, E is also irregular. Again, there's no definitive shape there. Okay? So, we have come to the end of section 8.1.3 on star systems. And so your homework is to read pages 411 through 416 if you haven't already done so. I really do encourage you guys to read it. I know you're watching a lot of the facts in the videos and stuff, but I can't possibly put it all in and keep the video short enough. And so please just read it. It'll really solidify your understanding better and cement some of those concepts that we've talked about here. I also have 2 linked videos that I think are super helpful and I would really love for you to watch, so please check down below, click those and watch those to really supplement your understanding of this lesson. And as always, complete the lesson review questions for 8.1.3 and email or send a picture of those to me when you have completed them. All right, and we will go over those answers next week in the video lessons. And with that, happy Friday. I hope you guys have a great weekend. Do something fun. Hopefully the weather's nice. Get outside, try something new, all right? I will see you guys next week.